Okay, guys, I just wanted to go over a couple of things with you because before we were out for spring break, we had um an interactive notebook to do, and I noticed that we had some trouble with conjugate acids and conjugate bases. And so I wanted to go over those again, and then you're going to have um, on quizzes, you're going to have, it's called Conjugate Acids and Bases Practice. And it's going to be 20 questions. You're going to be able to do it more than one time. And I'll take, whatever your highest score is or whatever your last score was, I guess. I don't know exactly how it works. I'm still figuring out quizzes. But anyway, you're going to do this practice and after you watch this video. And so I wanted to use just a few minutes to go over with you what a conjugate acid and what a conjugate base are. Because I know it's been a while since we talked about it, and some of you had trouble with it when you did it on that interactive notebook. Again, we have conjugate acids and conjugate bases when we use the Bronsted-Lowry definitions of acids and bases. Okay, remember with Bronsted-Lowry, an acid is a proton donor, so it has to have a proton or hydrogen ions, and then a base is a proton acceptor. So basically, if we look at the examples that we have here, okay, this is our acid, and then this would be what we would call our conjugate base, okay, because an acid becomes a conjugate base when it donates a hydrogen ion. Again, a hydrogen ion is an H+. So when this HNO3 becomes NO3 minus, okay, how did it do that? Well, it donated an H+. So again, we have the HNO3 without the H, and then again, since that H is positive and it lost that positive, it became negative. So this is the acid, and we know that because it became this conjugate base. It lost this hydrogen ion to become this conjugate base, okay? So basically, another thing we want to look at here is that at the beginning of the equation, our reactants are going to be an acid and a base. And then at the end, our products will be a conjugate acid and a conjugate base. So again, an acid becomes a conjugate base after it donates that hydrogen ion. So the acid is at the beginning of the equation, and then the conjugate base is after, at the end, after the arrow. So the acid and base are always before the arrow, and then the conjugate acid and conjugate base are always after the arrow. So again, this HNO3, it donated a hydrogen ion. That's how we know it was an acid, and it became this. It became the NO3 minus when it donated a hydrogen ion. And once we have picked out the acid and the conjugate base, then we know then this other thing has to be the base, and then this is the conjugate acid. Again, how do we know the base and the conjugate acid? Well, the base is a proton acceptor. So again, we have something here in the reactants that accepts a proton. It accepts a hydrogen ion. So what will happen is it will have one more hydrogen ion that it had before at the end, and it will have a positive charge. So I can tell, if we go back to this one, this was our base. The water here, the H2O, was our base. How do I know that? Well, after the reaction, it is now H3O+. How did it become H3O+? It accepted a hydrogen ion. So the water acted as a base. It accepted a hydrogen ion and became H3O+, and so this is our conjugate acid, okay? So this is our acid. It donated a hydrogen ion and became NO3 minus. That's our conjugate base. And then this is our base. How do I know it's a base? Well, it accepted a hydrogen ion and became H3O+, so this is our conjugate acid. So when bases accept a hydrogen ion, they become conjugate acids. When acids donate a hydrogen ion, they become conjugate bases. So we have acid, conjugate base. We have base, conjugate acid. So the acid and the base are in the reactants, and then the conjugate acid and the conjugate acid here, the conjugate base here, they are always going to be your products. We can use the same process in this one. Okay, I noticed that NH3 became NH4+. How did it do that? Well, it accepted a hydrogen ion. So then that tells me that this NH3 was my base, and then this NH4+ is my conjugate acid. If we look at this, it must have donated a hydrogen ion. Let's see if it did. Well, H2O became OH-. How did it become OH-? Well, it donated a hydrogen ion. It lost a H, so it has only one H now, and if it lost a positive, then what's left is negative. So H2O became OH-. So this is our acid, and this is our conjugate base because the water donated a hydrogen ion. That makes it the acid. And then what's left after it donates the hydrogen ion is the conjugate base. So again, the base and the acid are always going to be your reactants. And then your conjugate base and your conjugate acid are always going to be in your products. So you won't have a conjugate anything at the beginning. It will always be an acid and a base. At the end, that will be your conjugate acid and your conjugate base. And again, they are pairs. So this base became our conjugate acid. So that's our base conjugate acid pair. And then this acid became our conjugate base. So this is our acid conjugate base pair. Okay, so they always exist in pairs. So I wanted to look at a couple of other definitions here, or a couple of other examples. Something that we haven't really talked about yet are going to be our polyprotic acids. You've looked at them in the PowerPoint, but we haven't really talked about them. Polyprotic just means it is an acid that has more than one hydrogen ion. So something like HCl would be monoprotic. But let's take, for example, H2SO4. Okay, H2SO4 is polyprotic. Specifically, it's diprotic, meaning that it has two hydrogen ions. So if it's an acid, then it's going to donate a hydrogen ion. Obviously, this is an acid because it has hydrogen ions to donate. So this is our acid. And then when it donates a hydrogen ion, okay, so we get rid of one hydrogen ion, and we also get rid of a positive. So when you lose a positive, you become more negative. So HSO4 minus would be the conjugate base of that acid. But let's look here. HSO4 minus has another hydrogen ion that it can donate. So H2SO4 is our acid. HSO4 minus is the conjugate base to that acid. And again, I'm putting conjugate base here, CB, just to abbreviate. So now let's say that we have HSO4 minus. Okay, it can also act as an acid and donate another hydrogen ion. And if it does that, then it's going to lose one more hydrogen ion, so that means there won't be any hydrogen left. It'll just be SO4. And we also lost a positive, so now we're going to be 2 minus. So if HSO4 is our acid, then our conjugate base is SO4 2 minus. Okay, so again, notice that H2SO4 can donate 2 hydrogen ions. When it donates 1 hydrogen ion, it becomes HSO4 minus, and so HSO4 minus is the conjugate base to H2SO4, the acid. But this HSO4 minus can still act as an acid because it still has another hydrogen ion that it can donate. And remember, that's the definition of an acid, a hydrogen ion donor. Okay, so if HSO4 minus is acting as an acid and donating another hydrogen ion, then SO4 2 minus is its conjugate base. So again, this is our acid conjugate base pair. If we have HSO4 minus and SO4 2 minus, H2SO4 and HSO4 minus is another acid conjugate base pair. Okay, now you could look at this backward as well. You could look at this as, okay, SO4 2 minus can accept a hydrogen ion, and it could become HSO4 minus. Okay, if it did that, then it's acting as the base, and when it accepts that hydrogen ion, this is our conjugate acid. So it just depends upon which direction you're looking. The same thing here. This could still accept another hydrogen ion to make it neutral because it's negative. If it accepted one more positive, it would be neutral. So if this HSO4 accepts a hydrogen ion, remember that's a base, a hydrogen ion acceptor. If it accepts a hydrogen ion, then it is a base. And then the H2SO4 would be the conjugate acid to that base. Okay? So it just depends upon which direction you're looking. And when I give you problems, then you're going to be looking at, just look from left to right. And you should be able to look, just like we did on the PowerPoint, you should be able to look. And I'm going to see if I have any more examples on the PowerPoint for you to look at. Okay, this is another example on the PowerPoint. So here we have, okay, how do I know which one's the acid and which one's the base? How do I know? Well, I look at what they become, okay? So I look at the beginning and look at what it became at the end, and that tells me whether it accepted or donated a hydrogen ion. So when I look at this one, HC2H3O2 became C2H3O2 minus. How did it do that? It lost this hydrogen ion. It donated a hydrogen ion. So since this donated a hydrogen ion to become that, then this has to be my acid because acids donate hydrogen ions. So C2H3O2 is my acid, and then the C2H3O2 minus is the conjugate base. Again, acids have a conjugate base. After the acid donates its hydrogen ion, it becomes the conjugate base. So then when we look at the water, well, what did the water become? The water became H3O+. How did it do that? It gained a hydrogen ion. Well, that's the definition of a base, accepting a hydrogen ion. So the H2O is our base, and then when it gained that hydrogen ion, like bases do, then it became H3O+, and so that's our conjugate acid. So our pairs here, HC2H3O2 and C2H3O2 minus, that's our acid conjugate base pair. And then the H2O, H3O plus, that's our base conjugate acid pair. So again, how do I know which one is which? Well, I look and see what was it before the reaction? What did it become after the reaction? That tells me what it is. If it lost a hydrogen ion, like we see with these two, then this was our acid. Again, before the reaction, you have your acid. After, this is your conjugate base. And then I look at this one, it became this. So then this is our base, and this is our conjugate acid. How do I know that? Well, the H2O had to accept a hydrogen ion to become H3O+. So basically, what we see here is the hydrogen ion went from the acid to the base. Okay? The hydrogen ion went from the C2H3O2 to the H2O. And so that's how we ended up at the end with C2H3O2 minus plus H3O plus. So I hope that helps you to understand the concept of conjugate acids and conjugate bases a little bit better. Again, always remember that you will always have the acid and the base at the beginning in the reactants, and then in the products, you will have your conjugate acid and your conjugate base. Again, the acid has a conjugate base. We call that an acid conjugate base pair. And then the base has a conjugate acid. We call that the base conjugate acid pair. Again, how do I know which one is which? Well, I look at what happened. If it donated a hydrogen ion like this one did to become this, then I know this was my acid, and that makes this my conjugate base. If it accepted a hydrogen ion like this one did to become this, then I know this is my base, and then this is its conjugate acid. So you have a base conjugate acid pair, and you have an acid conjugate base pair. I hope this helps you. Please let me know if you have any questions. Email me or send me a message here on Google Classroom. And, if we need to, we can Skype, we can FaceTime, whatever we need to help you understand that. I hope you have a great day, and I will be posting stuff throughout the day today and tomorrow. All of your work for this week will be due by Sunday night at around 11:45 p.m. I usually make it 11:55, but on quizzes, the latest it would let me make it was 11:45. So the quizzes, practice, anything I give you on quizzes will be due on Sunday night at 11:45. But anything else will be due by 11:55 on Sunday night, and that would be April the 19th. So I hope you have a great day and a great week, and we'll talk to you later. Bye-bye.